To the hall is a former Deputy Vice-Chancellor academic also. He came solidarizing. Please permit me to add Professor Ichie. Permit me to recognize the presence of Professor Ichie Christian Ikeobi. You're welcome, sir. I almost mistook Professor Ikeobi as a senator representing a senatorial district in the southeast today when I saw him. As I said, very soon the procession will file in. Every arrangement is in place. And once again, let's be reminded, today's inaugural lecture is titled Statistical Reasoning, a Panacea for National Development. We are having also the immediate past boss of the university. Immediate past bossa of the university, Dr. Chukwuwike Ezeazu. You're welcome, sir. We want to welcome also the team from the Information and Communication Technology, ICT Rec, FUNAAB. You're doing great, led by the acting director, Mr. Temitokbe Shoretire. You are highly recognized. And we recognize the presence of the Director of Works, Engineer Funsho Ipadeola. Sir, you're miles away, and we would appreciate if you can come a bit closer. I'm not leaving out the members of the Directorate of Public Relations who are actively present here, led by the acting head, Mr. Olajide Olasukomi, You're highly welcome. And the wife of the inaugural lecturer, the man of the moment, we recognize the presence of Mrs. Chinyere Agwuegbo. You're welcome, ma. And every member of the Agwuegbo's immediate family, you're highly recognized as you step into the hall. Please, before we start, okay. The procession is set. Any moment from now, they are going to file into the hall. But I want to appeal okay. All right, let's rise up for the procession. Please, let's rise for the procession. That is the procession comprising the deans and directors of various colleges and units. You're highly welcome. The national anthem, please.
Nigeria, we hail thee, our own dear native land. Though tribe and tongue may differ, in brotherhood we stand. Nigerians all and proud to serve our sovereign motherland.
FUNAAB anthem. Thank you very much. Let's have our seats. Let's have our seats. Once again, we are welcome to the Federal University of Agriculture, Abeokuta, and most especially to the 102nd Inaugural Lecture of this university. To make it quick, please permit me to run through the introduction of members of the procession on this side of the hall. And first on my roll call is our Vice-Chancellor, Professor Babatunde Kehinde, who is ably represented here by the Deputy Vice-Chancellor Academic, Professor Olukayode Akiyemi. Please a round of applause for him. You're welcome, sir. And next, to his left-hand side, is the man who just took the mantle of DVCD ship, permit me to use the word, our new and fresh Deputy Vice-Chancellor Development, Professor Mufutau Atayeshe. You're welcome, sir. We also have the Registrar, Dr. Titus Adeniyi, represented by Mr. Moses Anyoda. You're welcome, sir. And the Bossa, Mr. Olukayode Oshinoga, represented by Mr. Valentine Egbuna. You're welcome, sir. The university librarian is also seated. Please let's welcome Professor Abayomi Owolabi. And the Dean of our inaugural lecturer, who also doubles as the chairman, committees of deans and director. I'm talking of no one but the Dean, College of Physical Sciences, Professor Taufik Adio Akinwale. You're welcome, sir. Fortunately, today our inaugural lecturer is the head of Department of Statistics. However, he has chosen an able hand to stand in for him as the head of departments for this event. Please let's welcome the head of department, Statistics, Professor Olaniyi Matthew Olayiwola. You're welcome, sir. And lastly, we know statistical reasoning is the backbone of informed decision making, and its application is crucial to national development. It is also a powerful tool that enables policymakers to make informed decisions, drive progress, and foster a culture of transparency and accountability. To this end, permit me to welcome our inaugural lecturer for today, the 102nd Inaugural Lecturer of the Federal University of Agriculture, Abeokuta, a professor of Stochastic Modelling from the Department of Statistics in the College of Physical Sciences, Professor Samuel Obi-Nnamdi Agwuegbo. And he will be taking on the title, Statistical Reasoning, a Panacea for National Development. Permit me to also take a quick recognition of the Agwegbo's family, led by his beautiful and amiable wife, Mrs. Chinyere Agwegbo. You are welcome, ma'am. All the deans and directors, you're highly welcome. Please, a round of applause for the deans and directors in procession. And I want to recognize, especially before I hand over the microphone, you know, he just ran the race. He's still smoky as a DVC development in place. Now he has handed over the baton. Please let's recognize the presence of Professor Kola Adebayo. At this end, I want to specially invite the Vice-Chancellor, who is ably represented here by the Deputy Vice-Chancellor, the academic, Professor Olukayode Akiyemi, for the Vice-Chancellor's remark. Please, a round of applause for the Vice-Chancellor as he steps out.
Please, let's have a seat. At this juncture, and on behalf of the Vice-Chancellor of the Federal University of Agriculture, Abeokuta, Professor Olusola Babatunde Kehinde, I'd like to welcome you all to the 102nd Inaugural Lecture of this great university. And at this point, I'd like the inaugural lecturer to stand, come beside me here, and remain standing. The Deputy Vice-Chancellor, Development, the Registrar, ably represented by Mr. Moses Anyada, the Bursar, represented by Mr. V.C. Egbuna, the University Librarian, Dean, College of Physical Sciences, who also doubles as the Chairman, Committee of Deans and Directors, other Deans and Directors, heads of departments, programs, and units, distinguished members of the University Senate, all academic and non-teaching staff, all special guests and friends of the university, members of the families and friends of the inaugural lecturer, gentlemen of the press, distinguished ladies and gentlemen, great FUNAABites. I have the pleasure to welcome you all to the 102nd edition of the inaugural lecture series of the Federal University of Agriculture, Abeokuta, Ogun State, Nigeria. Our inaugural lecturer of today, Professor Samuel Obi-Nnamdi Agwuegbo, was born on June 29, 1962, in Enugu State, to the family of late engineer Samuel Emenike Nnamdi Agwuegbo and late Madam Eunice Ezimamaka Agwuegbo ni Ngbemena of Umuota Village, Obosi, Anambra State. He is the fourth child of 5 children. Professor S.O.N. Agwuegbo had his elementary education immediately after the Civil War at the Central School, Onitsha, Anambra State, from 1971 to 1974, where he obtained his first school leaving certificate. He obtained his West African School certificate in 1979 at the Community Secondary School, Obosi, Anambra State. And in 1981, he proceeded for a bachelor's degree program at the University of Nigeria, Nsukka, where he bagged a Bachelor of Science degree in statistics in 1985. He embarked on a postgraduate study in statistics at the University of Lagos, Akoka, Nigeria, where he got a Master of Science degree in 1993. He bagged a Doctor of Philosophy in Statistics at the Federal University of Agriculture, Abeokuta, Ogun State in 2010. Professor Agwuegbo worked briefly as an auxiliary teacher, Queen of the Rosary College, Nsukka, from 1980 to 1981, before proceeding to the University of Nigeria for his undergraduate programs. He did his National Youth Service Corps at the Cocoa Research Institute of Nigeria, Ibadan, 1985, under the Agronomy Department as a research assistant. He also worked at the Nigerian Reinsurance Corporation as a research statistician, after which he left to pursue a higher degree in Lagos. While on his master's degree, he worked at Bifex Consult as a principal consultant statistician, after which he secured an appointment at the Delta State University Satellite Campus, Lagos State, as an assistant lecturer in 1997. He joined the University of Agriculture, Abeokuta in 2000 as an assistant lecturer in the Department of Mathematical Sciences and rose through the ranks to the position of professor in 2021. The inaugural lecturer has held some administrative positions and responsibilities in the university, some of which are member, Technical Committee, 4th AMU PAMO Symposium on Training and Research at the University of Agriculture, Abeokuta in 2004. Member, Protocols and Publicity Committee, 1st International Conference on Science and National Development, organized by the College of Natural Sciences then in 2004. Acting Head, Department of Statistics from 2011 to 2015. College of Physical Sciences representative at the University Health Center Board from 2019 to 2023. He is currently the head of Department of Statistics. Service outside the university. Our inaugural lecturer took part as a member, Local Organizing Committee, International Conference of Mathematical Scientists, African Mathematical Union, Abeokuta, Nigeria, in 2003. He was the president of the Old Student Association of Community Secondary School, Obosi, between 2005 and 2010. Professor S.O.N. Agwuegbo has served as external examiners for both undergraduate and postgraduate programs at the University of Ibadan and University of Lagos, Akoka. Membership of professional bodies. He is a member of several academic and professional bodies, including Nigerian Statistical Association, International Biometric Society, American Statistical Society, Professional Statisticians of Nigeria. Professor Agwuegbo has published over 40 research papers in both foreign and local outlets. He has supervised numerous undergraduate projects, more than 20 master's students, and 6 PhD students in the field of statistics. He is happily married to Mrs. Emilia Chinyere Agwuegbo, and the union is blessed with lovely children. Distinguished colleagues, ladies and gentlemen, it is my pleasure on behalf of the Vice-Chancellor to invite Professor Samuel Obi-Nnamdi Agwuegbo, a professor of Stochastic Modelling, to deliver the 102nd Inaugural Lecture of the Federal University of Agriculture, Abeokuta, titled Statistical Reasoning, a Panacea for National development. Thank you for your attention, and God bless you all.
The Vice-Chancellor, the Deputy Vice-Chancellor Academy, the Deputy Vice-Chancellor Development, the Registrar, the Bursar, the University Librarian, the Dean College of Physical Sciences, other Deans and Directors, Head Department of Statistics, other heads of other departments, members of the University Senate, members of academic staff, members, non-teaching staff, members of my immediate and extended family, all special guests, friends, and friends of the university, gentlemen of the press, distinguished ladies and gentlemen, the great FUNAABers, the Vice-Chancellor, sir, with a humble heart and deep sense of gratitude to God Almighty, I stand before you all highly honored and privileged for this opportunity to present my contribution to knowledge as a professor of stochastic modeling in the Department of Statistics, College of Physical Sciences of the great university. My journey as an academician in this citadel of learning started as an assistant lecturer on 8th May 2000 and culminated in my appointment as a professor in 2021. This is the first inaugural lecture from the Department of Statistics and the fourth from the defunct Mathematical Science Department, from which the Department of Statistics emerged in 2005-2006 session, and the 102nd Inaugural Lecture of the Federal University of Agriculture, FUNAAB, Abeokuta, Nigeria. An inaugural lecture is an assembly at which professors give insight and ideas into their academic prowess. It is an opportunity for professors to inform colleagues, the university community, and the public of their work to date, their contributions to knowledge, the relevance of their work to the wider academic community and to the general public, as well as to discuss their present research and their future plans. One of the most visible changes in the world today is that automation has altered the way people think and make decisions. Many researchers rely on their conscience and the value they have learned to make decisions. Yes, we ask, what's the conscience? We should realize that before science, theology was, and the theologians were interested in conscience, and people felt that this is metaphysics because their interest is in esoteric and esoteric teachings. And they removed the con in conscience, and that is science, physical system. Sin is believing. So today, we are all interested in science, which is sin is believing. So we look at the decisions for thousands of situations each day, and we realize that what is needed is information. Information presently has the potential to be used as the basic currency for describing reality. Information is knowledge gained or received concerning a particular fact or circumstances through study, communication, research, instruction, and is factual data. Information is what results from thoughtful manipulation, analysis, and presentation of data in a form that will enhance decision-making process. My Vice-Chancellor, sir, based on this premise, I present my inaugural lecture, Statistical Reasoning, a Panacea for National Development. The phrase statistical reasoning is defined as the way one reasons with statistical ideas and understands statistical information. Statistical reasoning entails reasoning from combination of data to arrive at conclusion about what is true, false, likely, or improbable. Statistical reasoning are novel to the understanding of scientific research, and it plays an important role in new product designs, manufacturing processes, development, and process improvements. Statistical reasoning has helped countries like Japan to achieve economic growth and development. And it is all about planning and concluding and conducting experiments and about analyzing the resulting data so that valid and objective conclusions are obtained. Statistical reasoning concepts are best read in the context of real data sets. And these real data sets convey the importance and relevance of statistics, and it has real information that emphasize the problem-solving nature of the physical world. We have to realize that everything in life is defined by nature. And we in mathematical sciences, our interest is on universe and space. Universe is nature and space is nurture. Nature provokes all the entities into a systematic arrangement so that they can accept the discipline of the physical world. And the physical world defines the complexity that one faces in nature, and it exists in several entities such as physical, biological, psychological, and intellectual. All the entities are created by God, and God is existence, and existence is the cause of an entity. The basis for logic in our physical world is mathematics, and mathematics is the ultimate quest for absolute truth. Truth is the quality or state of a matter, and it is in conformity with facts. Today, statistical reasoning is all about facts, and facts are reality. And facts must be backed up with figures. That is the power of our imagination. In a broad sense, figures are used to suggest anything with a physical presence. Figures are numbers, numerals, symbols, integers, whole numbers, and fractions, things that are quantifiable. Thus, statistics relates to numbers and can be defined as the science of large number of things. Statistics is a branch of applied mathematics, and it provides tools for describing and reasoning from numerical information or facts, as we have in that figure 1.0. Practically speaking, statistics can be viewed in terms of scientific methods used in studying human behavior. Scientific method places emphasis on gaining knowledge through the process of observation. Whatever is said about observation is reasoned from systematic observation and is tested and retested by observations. Williams, 1979. Scientific method attempts to anchor knowledge in terms of physical reality using rigorous procedures, and these procedures can be reflected in the typical outline of scientific research plan in terms of the problem, method, and results. Science is a process of acquiring knowledge about empirical reality and is based on observation, and observation is defined as numerical recording of information, and statistics is the science of observation. The researchers' report of observation are considered as data. So data are reports of observation of variables. And variables are observable characteristics of an object or an event that can be described according to some well-defined classification or measurement scheme. Stevens, 1946, proposed a 4-scale measurement that are available to researchers today because different measurement scale offer varying degrees of exactness in describing characteristics. So in trying to do that, Stevens proposed the nominal, ordinal, interval, and ratio as a way of classifying measurement scale. As observation and measurements have been undertaken, the researchers get a body of measurement data as in figure 2. In context of analysis, the data can be classified in figure 3. It is pertinent to note that any process of observation in science is called experiment. And the experiments are performed by investigators in virtually all fields of human endeavor, usually to discover something about a particular process or system. Formally, an experiment is a test or series of tests in which purposeful changes are made to input variable of a process or system so that reasons for change in the output response may be identified. Montgomery, 2001. In any experiment, the results and conclusions that can be drawn depend to a large extent on the manner in which the data were collected, as in figure 3. The demand for more and better statistical reasoning has brought to the forefront burner the importance of statistics as a strategic resource for national and international development. Statistics is now recognized internationally as part of the enabling environment for national development. National development is the capacity of a country to raise the standard of living of its population and is empirically necessary and sufficient for human well-being. It is the ability of a country or countries to improve the social welfare of the people, for instance, by providing social amenities like quality education, potable water, transportation, infrastructure, and medical care. National development is very comprehensive to include the political, economic, social, cultural, scientific, and material spheres of an individual and the nation, and it is holistic in approach. Statistical reasoning is a powerful tool that can drive national development by enabling informed decision-making, policy formulations, and resource allocation. The Vice-Chancellor, sir, permit me at this point to quote Mark Twain, 1882, who avowed that human nature is the same everywhere. It defines success, and it has nothing but scum for defeat. All you need in this life is ignorance and confidence, and success is sure. Yes, that is the only mathematical equation that solves the whole problem of the world. And that equation is success is equal to ignorance plus confidence. Mathematically, we translate it to equation 2. So if you look at that equation, success is predictable, for success is an output. If you are successful, it's not a hidden people will know. But success is necessarily not determined by material possessions or accomplishments. Ignorance, on the other hand, is lack of knowledge. And knowledge is cumulative, and once it exists, it does not cease to exist. It becomes available to more and more people, and it grows exponentially. Knowledge is power, and every new piece of knowledge reveals connections and interconnections with other areas of knowledge in a self-reinforming and accelerating pattern. Successful people are confident and can lead themselves as well as others. They have their own vision and mission and seek to bring them to life. The difference between ignorance and confidence is that ignorance is lack of knowledge or information, while confidence is judgment upon the accuracy of a conclusion or the extent of one's ability. The margin of error and the level of confidence are tied together. The greater the confidence level, the larger the margin of error. While the smaller the confidence level, the smaller the margin of error. The equation 1, which I said that is success is equal to ignorance plus confidence, mathematically can be translated as in equation 2. Equation 2 refers to the real-life system, and this process can be represented as in figure 4. The figure 4 shows us that if you impute, according to the economics, if you impute all the factors of production into a system, you are bound to have outputs of goods and services. And that is what we have shown in figure 5 by trying to see how we can impute those factors of production to achieve as results. Figure 5 is clearly understood when it is comparatively easy to predict or measure the system's output for a specified input using mathematical expressions for the real-life system as defined in equation 2. All real-life systems, whether simple or complex, such as business, politics, medicine, education, are easy to predict using equation 2. For instance, the Prussians used it to develop the educational system as an advancement of learning and fulfillment of social and cultural desires of the individual, and for others, it is to meet manpower requirements of the economy. The Vice-Chancellor, sir, it is commonly believed that anyone who tabulates numbers is a statistician. This is like believing that anyone who owns a scalpel is a surgeon. Hook, 1983. Ephron emphasized that those who ignore statistics are condemned to reinvent it, since statistics is the science of learning from experience. Remember that experience is the best teacher, and these are a way of acquiring knowledge. Statistics as a discipline should and will continue to gain influence and visibility, though in Nigeria, statistics lacks identity and visibility. Most of statistics that is practiced for serious purposes today, whether for academic research, for industrial product development, for business, in government, or for any other purposes, is carried out by non-statisticians without professional statisticians' assistance. Only a few enlightened industry have professional statisticians on their staff list, and few of these employees carry the title statistician. Other evidence is at hand that statistics as a profession lacks visibility. This is not to suggest that all these aspects are necessarily bad. Only that statisticians are yet to be accepted by the academic, industry, or business world as professionals representing an accepted discipline. Statistics as a field is more than rules and methods for dealing with data. It has become a way of acting and thinking about the world. Statisticians realize this and use statistical methods in their professional lives to help scientists and policymakers in their work. But more than that, statistical training contributes to an understanding of the world around us. In an increasing scientific and technological world, the demand from industry and business and commerce is for men and women who are both literate and numerate. Just as good literary education is recognized as providing a base which enables and permits continuing and effective means of communicating, the ability to understand and discuss problems numerically is fast becoming a prerequisite for survival in a continually changing world of ours today. Here, one of the results we want to provide here is the ability to understand problems numerically is becoming a prerequisite. And today, it is evident that any university that wishes to survive in a changing world of ours today must be kept abreast of the available technology as far as academic curriculum is concerned. And one of these constant and cyclical advancements is what we call the university and technology today is introduction of the triple helix. The triple helix is a concept that brings the university, the industry, and the government together. So the Vice-Chancellor, sir, permit me to discuss this concept as the potentials for innovation and national development in knowledge-based society. So the triple helix thesis is more prominent role for the university in hybridization of elements from university, industry, and government to generate new institutional and social formats for production, for transfer and application of knowledge. The concept of entrepreneurial university is also a central concept from triple helix, and it takes proactive stances in putting knowledge to use and in creating new knowledge. It operates according to an interactive rather than a linear model of innovation. As firms raise their technological level, they engage in higher levels of training and knowledge sharing. As universities develop links, they can combine discrete pieces of intellectual property and jointly exploit them. My research activities over the years reverse round the modeling of dynamic behavior in large dimensional state space by exploring structures in complicated data. Interest in my studies cut across multivariate analysis, stochastic processes, and time series analysis. In multivariate analysis, we aimed at examining the interdependencies or dependencies of many factors at the same time, because realities are multivariate, many factors at the same time. So we try to see how we can model these many factors simultaneously at the same time, not using the concept of ceteris paribus. For ceteris paribus is all things being equal, but all things are not equal. So for us to discuss this concept, we move back to the basic idea of modeling arising from simple probability. And here we say that the major advantage of modeling is based on conditional model. Because one thing that is obvious is that no matter the discipline you are faced with analysis. And analysis is transforming data to information. Statistically, that's why we said every discipline that wants to go scientific must go by way of analysis, and that is statistics. And analysis to us is defined in two ways. Either the event is independent, identically distributed, or is a conditional model. But realities are conditional models. So for us to discuss that modeling, we moved here by saying if S, Y, Z are the random variables, then the joint distribution can be written in terms of factorization as defined in equation 3. And this is the simple cross of hierarchical thinking. So we look at how do we model realities in the agricultural world, in other spaces in life, and this boils down to this case of Agwuegbo Adebute 2006. In Adebute Agwuegbo 2006, we applied hierarchical clustering algorithm on 226 sections of Virginia vesicillata, that is COLPHYS, collected from 6 African countries. We tried to solve the problem by defining similarities and dissimilarities, and the cluster ended up in 2 groups showing a breaking point at a distance of 0.275. The results showed that this clustering approach is useful in rationalizing taxonomic groupings of multidimensional data in biological sciences. Also, Agwuegbo et al. 2012, we worked on tilapia cabria, the morphological features of tilapia cabria using average linkage clustering algorithm. The data was obtained from a study by Uchendu and Wishi 2007. The morphological study of the tilapia was shown in figure 6, and all the other necessary things in the morphological features is categorized in 2 groups and is summarized in table 1. Using the Mojena scheme, we were able to identify that the simple average, the simple linkage cluster, partition this into 2. And the result from the study, in fact, that morphological features in group 1 are similar as they determine the size of tilapia cabria. Also, the idea of multivariate analysis was also used in Adogo et al. 2017 on chemical radicants of water in hand-dug wells. 40 hand-dug wells were sampled within the metropolis of Akure using standard laboratory techniques. The water silicates, the spotter samples were analyzed for chemical radical parameters such as calcium, magnesium, sodium, potassium, iron, lead, silicate, phosphate, sulfate, bicarbonate, chloride, nitrites, and nitrates. And the resulting data was subjected to principal component analysis, and the result was as shown in 3 and 4. In figure 7, we show the bi-plus and radicals. And in table 3 and 4 shows what we have done using the principal component analysis. Also in Agwuegbo 2002, a matrix inversion technique was applied for multivariate problem. So with that, we try to solve multiple linear regression problem where explanatory variables are linearly dependent. And we solve that problem. Note that matrix inversion represents both fundamental mathematical operations and the practical computational challenges across countless disciplines, such as engineering, physics, computer, data science, and statistics. But we applied that concept and we were able to resolve that problem. We also, in Agwuegbo 2022, we applied that using consumer price index. All right. For both urban and rural area, and this data was gotten from Central Bank Statistical Bulletin, and we discovered that over 90% of the variation in price of the food items at urban centers is caused by the price in the rural areas. We also did other research in multivariate analysis by looking at Adewale et al. Using neural networks and multivariate discriminant analysis. This model was developed for varieties of cowpeas planted in Kano. And the results also shows that the neural network performed better than the multivariate discriminant analysis in the process of selecting new cowpeas. Also, we moved further in Agwuegbo 2010 to look at the outside the agri world, and we looked into the financial world, because recently there is growing attention outside the banking world, and we now move to the insurance industry. So in Agwuegbo 2010, we used the factor analytic approach to study insurance investment in Nigeria, because we know that their investment contributes to the well-being of the country. And that is why we say it has a lot of impact in national development. So we look at the insurance contribution. The data set also was extracted from central banks, and the study showed that 2 latent factors are enough to adequately capture the information contained in 5 investment variables. And this is shown in table 5. And the first factor is positively correlated. I also move further to the study of dynamical systems by exploring stochastic processes in discrete time. So in trying to solve that problem, we discovered that the structure, these stochastic processes can only be achieved using what we call the Chapman homolograph equation in order to define the assembling average. The Chapman homolograph equation was shown in question 6 and 7 and 8, and we applied that in Agwuegbo 2006 where 4-stage space model were developed for rainfall in Abeokuta. So we use stochastic process to define the wet and dry season, and we partition it into 4 stages. And we have those results there. We also apply that Chapman-Kolmogorov equation in Agwuegbo 2010, where we analyzed the stock market in Nigeria. 60 quoted companies were looked into, and the results were also solved. And we discovered that there is a concept of in there, and as shown in table 6. So the result from the study provided evidence that Nigerian stock exchange is not efficient, but it's a random walk. The random walk is presented with the specific aim of giving definite description of the Nigerian stock market prices. In a world without interest rates, the idealized stock price is a martingale. Martingale defines fairness, unfairness of an investment, and no investor can alter the stock price as defined by expectations. We also move further in Agwuegbo 2014 to predict wind speed, the wind speed in Nigeria, using a signal model. The equation for that, the defining condition of that is defined in equation 12, and that equation 12 is nothing but a random walk model. In Agwuegbo 2017, we applied the hidden Markov model approach to predict exchange rates in Nigerian foreign exchange markets. The hidden Markov model is typically defined and represented as a stochastic finite automata, which is assumed to build up from a finite set of possible states, as shown in Agwuegbo 2017. The equation 13, 14, 15 defines the hidden Markov model as an ARIMA model. We realize that every ARIMA model is a random walk model. And so that is the thing, but it's an integrated model and a sophisticated model by Boss and Jenkins. So we have shown that the time plots in figure 8 and the ACF and the PACF in 9 and 10. In Agwuegbo 2014, we explored a class of state-dependent models for the analysis of inflationary rates. And the state-space model represents physical system based on Markov property. From the results, the optimal order in our state-space model for inflationary rates is defined as an autoregressive of order 1. Then we introduce the state-space model, but using a recursive estimation procedure called the Kalman filter. And based on that, we were able to compute the ACF and the PACF for the model. Agwuegbo 2010 also explored the application of the convolution on chaotic dynamical systems. The mathematical representation of the chaotic processes is as shown in 16 and 17. Equations 16 and 17 are examples of what the mathematicians call difference equations, but which we in statistics refer to as deterministic time series. The time plot of the data set in the study is as shown in figure 11. If you look at figure 11, you see that it's highly chaotic. But we were able to handle that problem, and we come out using a deconvolution process, and we have that as in equation 16. This is the time plot showing the diagnostic check, and we see that it's an adequate modeling that process. Also, in Agwuegbo et al. 2010, we introduced the concept of a continuous time processes using stochastic differential equation, and the since stochastic differential solution to stochastic differential equations are Markov processes, and we have that formula as in 18, and also in 19 we define that stochastic by a first order autoregressive process, and equation 20 also shows the mathematical representation of the process up to 22 to 23. So we apply that in trying to study monthly crude oil prices, and we came out with the result as an Austen-Uhlenbeck equation. The Austen-Uhlenbeck equation is what we call the mean reversion. So what we are saying is that no matter the price, it will reach a stage, it will revert back. So in that case, we agree that crude oil prices is a commodity, and every commodity today is now a goods. And that is the interest in finance and economics. So we are talking of the concept of derivatives. So in Agwuegbo 2010, we look at the sudden structural changes, and we use hierarchical model in the same claim process we have used before, and we saw here that we have this realization as in Fig 13 as a Brownian motion. So we tried to resolve that problem. In Agwuegbo 2014, we applied Kalman filter in resolving a problem. So the Kalman filter is as defined in the equation there, with the Kalman gain and the error defined. Statistical reasoning involves taking important decisions on facts and figures. It is a powerful tool that provides a plausible platform on which to base arguments. In the absence of good statistical concepts, data is nothing but a mere array of characters or digits with no meaningful insights. Only statistics can make a data speak, and that is what we refer to as information. Information are needed to provide useful development drives in all facets of our life. Typically, in institutionally based research, no discipline can go scientific except by way of statistics. In health, statistical reasoning is a vital key for ailment diagnosis. In industry, statistical quality control concepts are needed to monitor product conformance to standard as well as industrial progress. Through a statistical mindset, government at different tiers can make informed decisions, formulate policies, optimize resources, and solve economic problems targeted to improve quality of life of citizens. My experience over the years as a professional statistician have shown that statistics is an indispensable tool, and good, reliable statistics are essential for measuring progress, reaching development goals, and providing essential information about the effectiveness of policies and programs for national development. The informative and context derived from statistical reasoning can help to shape important decisions that have local, national, and global impacts. My Vice-Chancellor, sir, statistical reasoning is a vital tool for harnessing nations' potentials and unlocking new opportunities, mitigating risk, and build up a brighter future for the citizens. My recommendations are as follows: the government can develop capacity building by establishing a robust monitoring and evaluation framework to track progress, identify areas for improvement, and inform policy adjustment. That research and innovation to address national challenges such as poverty, health, education, and economic development must be supported by government and organizations. The government should establish and promote data accessibility by establishing open platforms and portals, by making national data available, accessible, and usable for research, innovation, and development. Also, for our university here, we suggested that the government should integrate statistical literacy by incorporating statistical reasoning into postgraduate curricula in FUNAAB to enhance critical thinking and informed decision making. Also, that the university should develop capacity building by providing what we call the train the trainer. The train the trainer workshop on statistical reasoning for administrators, for academics, for technical staff is needed. There was a time they were doing it, but I don't know what went wrong. Then we move by saying that embracing statistical reasoning in individuals, organizations, and nations should adhere to the concept of parsimony in everyday life decision making. The concept of parsimony is needed in whatever we do in order to reduce wastages, because there is a lot of wastages in the system. Further collaboration by encouraging partnership between government, academia, and private sector to leverage statistical expertise and resources for national development is also needed and is required. I remain grateful to God Almighty, the author of life, through the grace of our Lord Jesus Christ, the Alpha and the Omega, for his benevolence, goodness, and mercy, and compassion for guiding me through this journey of life so far. I owe an immense gratitude to Professor A.R.T. Sholare, who facilitated my journey to this citadel of learning. He was also my major supervisor with late Professor Shribo and Ademiwa, late Professor Ademiwa, as co-supervisors for my PhD program. I'm also grateful to the Vice-Chancellor, Professor Obi Kehinde, and his management team for giving me the opportunity to present this 102nd Inaugural Lecture. I would also like to appreciate the following former Vice-Chancellors: Professor Julius Okoje, late Professor Adu, Professor Ishola Adamson, Professor Lai Balogun, Professor Ololade Enikome, and Professor Felix Salako. I thank them all for the opportunities they gave me to be of some service to this great university. I also thank the present Deputy Vice-Chancellor, Academic, Professor Odi Akiyemi, and Deputy Vice-Chancellor, Development, Professor Atayeshe, the Registrar, the Dr. T.A. Adeni, the Bossa, Professor Shinoga, and the librarian, Professor Owolabi. I would like also to appreciate the former deans of the defunct College of Natural Sciences, Professor T.O.S. Popola, under whom I served as an acting head of Department of Statistics in 2011, and former deans of the College of Physical Sciences, Professor Catherine Eremosele and Professor Mustafa, and very sincerely, Professor A.T. Akiwale, the present dean of COLPHYS. Also, I remain grateful to all the deputy deans of the College of Physical Sciences, Professor Eka Akelabi, Professor Makinde, and presently, Professor Oshinoga. I enjoy working with you all. My regards also goes to my colleagues in the Department of Statistics, both academics and non-academic staff, with whom I have worked ceaselessly over the years and who have inspired me to provide the needed leadership. To my fellow HODs in COLPHYS and to all professors in COLPHYS, I thank you all. Special thanks to all members of the Igbo community, especially Professor Ikobi, Mr. and Mrs. V.C. Ebuna, Mr. Madubuko, and Chris Awe Matthias. I sincerely acknowledge all the students of the Department of Statistics, for they are ones who make it all the while, worth the while. I thank my postgraduate students in the Department of Statistics for their diligence, resilience, and also the financial support. I appreciate my neighbors in Wonderland Estate. Thank you all for the support and magnanimity. I appreciate all my friends and well-wishers, too numerous to mention here, who are grasping for breath in the suffocating struggle of life. I wish you all and sundry success in your endeavors. I also express my profound gratitude to my in-laws and for their concern, encouragement, and prayers. I am grateful to my maternal grandfather, late Pa Gabriel Mbaka Mwemena, 1894 to 1987, and late Madam Victoria Ilonwa Mwemena, 1911 to 87. They guided me and ingrained in me and my siblings the core values for fulfilling life. I'm so happy that my immediate junior brother, Engineer Obi-Nnamdi Agwuegbo, came all the way from Germany to be physically present in this occasion. Please, can we recognize him here? That's Obi. All right. I have no business in this citadel of learning if not for the support of my wonderful parents, late Engineer Samuel Nnamdi Agwuegbo, 1912 to 1970, and late Madam Eunice Eziamaka Agwuegbo Nimbemena, 1932 to 2014, for bequeathing excellent legacies in me and my siblings. To my lovely kids, Bubes, Kosi, Chido, Ama, and Ozamaka, I love you all dearly. My deepest appreciation goes to my wife, Mrs. Emilia Chinyere Agwuegbo. You deserve my love, respect, and gratitude for keeping the home and for enduring my frequent absence from home. I thank you all for listening as I present my inaugural lecture. So the references for my work is on here. I try to.
Let's have a seat. Another round of applause for Professor S.O.N. Agwuegbo. On behalf of the Vice-Chancellor of this great university, Professor Olusola Babatunde Kehinde, I'd like to formally congratulate Professor S.O.N. Agwuegbo for the successful delivery of the 102nd Inaugural Lecture of this great university. But permit me to acknowledge the academic family. Permit me to acknowledge the academic family of the inaugural lecturer, as well as the biological family of the inaugural lecturer, especially the wife of the inaugural lecturer, Mrs. Chinyere Agwuegbo. Thank you, Ma, for coming. You can have your seats. It is also my honor to acknowledge the presence of the son of inaugural lecturer, Mr. Ebube Agwuegbo. Let me also appreciate the presence of the former principal officers of this great university who are here today, starting from the former Deputy Vice-Chancellor, Academic Professor Catherine Eromosele. We also have in our midst today the immediate past Deputy Vice-Chancellor, Academic of this great university, Professor C.O.N. Ikeobi. We have the immediate past bursar of this university present here, Dr. Chukwuwinke Esepiasu. And my friend, who is looking at me here, the immediate past Deputy Vice-Chancellor Development is here, Professor Kola Adebayo. And at this point, we have come to the end of the 102nd Inaugural Lecture of this great university. On behalf of the VC, I'd like to thank you for coming, and we hope to see you at the next inaugural lecture. Thank you very much.
Thank you very much, sir. Statistical Reasoning, a panacea for national development. Before we draw the curtain for this 102nd Inaugural Lecture, please permit me to take the quick announcements. The procession we file out in reverse order through the center aisle of the hall, while academic staff in the hall who are not in the procession will go through my right-hand side, the door through my right-hand side, exit A, outside. The non-teaching staff will go through exit B by my left-hand side, and the special guest of the inaugural lecturer we file out also through the center aisle, and when they descend the staircase, there's a door by the left-hand side where the inaugural lecturer wants to give them a special treat. And for students, you are enjoined to remain in the hall. So please may we rise for FUNAAB anthem, to be followed by the national.
Great and blessed, for the mouth is far and near.
Thank you very much. Please, we are to remain standing while the academic procession files out. National anthem, please. I beg your pardon.
Though tribe and tongue may differ, in brotherhood we stand. Nigerians old and proud to serve our sovereign mother. Oh, man is oppressed, and the soul with peace of Nigeria may be blessed.
Thank you very much. Please, we are to remain standing while the academic procession files out. We want to appreciate every one of us who has made it to this 102nd Inaugural Lecture of the Federal University of Agriculture, Abeokuta. Special appreciation goes to the Vice-Chancellor, ably represented here by the Deputy Vice-Chancellor Academic. And to all our deans and directors, we say thank you. Our immediate past principal officers, we appreciate your presence. The lecturers, the immediate family, and to all FUNAAB staff and students here present, we say thank you, and we look forward to seeing you in the next inaugural lecture, the 103rd inaugural lecture of the university, which will be coming up soon.